Assalamu alaikum. Dear students, welcome to the online lectures of Organic Chemistry Chem 322. Today we will be discussing elimination reactions. Before this, in the previous lectures, we have discussed in detail the substitution reactions. Just to remind you people that this course of Chem 322 is comprised of three portions or three chapters. One is the substitution reactions, the second one is the elimination reactions, and the third one is the spectroscopy. In the previous lectures, we have covered the topic of substitution reactions, and now we will start the elimination reactions topic. Before going to the elimination reactions, just to remind you people that how many types are, what are the organic reactions, or reactions in organic chemistry. As you know, there are different types of organic reactions in organic chemistry to synthesize compounds. But all the types of organic reactions may be more than thousands, but these all are based on some basic or main types of organic reactions. First of these is the addition reaction. In the addition reaction, a group or a molecule is added to a substrate and we get a new compound. The second one is the substitution reaction. The substitution reaction we have studied in the previous lectures in very much detail. In this, one group is replaced by another group, or one functional group is replaced by another functional group, and we get at the end a completely different molecule or different compound. The third class of main types of organic reaction is the elimination reaction. In the elimination reaction, a molecule or a group of molecules is eliminated from a substrate or from a compound, and we get another unsaturated new compound at the end. The fourth class, the main class, is the oxidation reduction reaction. In this class of compounds, in this class of reaction, a group or a functional group or a moiety in the molecule is either oxidized to a higher oxidation state or reduced to a lower oxidation state, and we get a new compound. Now, what is the elimination reaction? Elimination reaction is a reaction in which elements of starting material are lost and a new bond is formed. Like, look into this molecule. It has two groups attached to the carbon-carbon moiety. Two moieties are attached to the carbon-carbon compounds, that is X and Y. In the presence of a reagent, they lose these two moieties and we get CC double bond, or carbon-carbon unsaturated compound at the end. How this removal occurs, or why this removal takes place. The removal usually takes place due to the action of acids or bases on the substrate. But it is not limited only to the acids and bases. This removal may occur due to the high temperature to the substrate. If the substrate is heated at high temperature, the bonds can break and we get an unsaturated compound at the end. In an elimination reaction, two groups X and Y are removed from the starting material. as we have seen in the previous slides. Two sigma bonds are broken and a new pi bond is formed between the adjacent carbon atoms. The elimination commonly occurs when the X is hydrogen and Y is an heteroatom that should be more electronegative than carbon. In normal circumstances, this is usually the halogen or oxygen, nitrogen, and these type of groups. But other groups are also possible that may exist in the substrate. In addition to substitution, an alkyl halide can undergo elimination reactions. This is a typical alkyl halide, propyl halide, and if we add Y, so it may occur or it may induce the substitution, like here, the substitution reaction. Or it's possible that an elimination reaction may occur and a new double bond will be formed in the substrate. Look into this molecule. This is an alkyl bromide. In the presence of a base, it will lose the bromine and the adjacent hydrogen, and we will get an unsaturated alkene or CC double bond. Similarly, the acid catalyzed reactions may also occur, like look into this example of cyclohexanol. In the presence of sulfuric acid, it will lose the hydroxyl and one hydrogen, and we get a double bond between the two adjacent carbons, or at the end we will get cyclohexene molecule. What is the purpose of this reaction? Why it is used? The main purpose of this reaction is to transform the saturated compounds, that is, the organic compounds which contain single carbon-carbon bonds, to unsaturated compounds. These are the organic compounds having double or triple bond between the two adjacent carbons. So the main purpose is the creation of unsaturation. It is the principal process by which organic compounds containing only single carbon-carbon bonds or saturated compounds are transformed to the compounds containing double or triple carbon-carbon bonds, that is the unsaturated compounds. Like you can say that you can make the alkene and alkynes by this method. The elimination reactions have different types, but they have been distinguished by the kind of atoms or group of atoms that are involved in this reaction, that leave the substrate. Due to this, there are two main methods involved in this type of reaction. One is the dehydration or removal of water, and the other is dehydrohalogenation or removal of a hydrogen halide from the substrate. When the water is removed or the hydrogen halide is removed from the substrate, we will get an unsaturated compound, or you can say an unsaturated alkene type of compound. Elimination reactions are classified as E1 or E2, depending upon the reaction kinetics. In an E1 reaction, the reaction rate is proportional to the concentration of the substance to be transformed. In an E2 reaction, the reaction rate is proportional to the concentration of both the substrate and the eliminating reagent. But the elimination reactions are also denoted by another name, that is beta elimination. Why? Because it involves the elimination of a proton from the beta carbon forming a pi bond and ejecting a leaving group. But there are some alpha elimination reactions too. It is not necessary that all the eliminations will be beta elimination. The alpha eliminations are also possible. But apart from alpha and beta elimination, there is the possibility of 1,4 and 1,6 eliminations, which are not in our course, so we will not be discussing these reactions. Look into this. When two groups are lost from the adjacent atoms so that a new double or triple bond is formed, one group is the alpha and the other is the beta. Here, the carbon to which the heteroatom is attached, in this case the bromine, that is alpha carbon. And the carbon adjacent to that alpha carbon is the beta carbon, and if a proton is lost from the beta carbon, so that will be beta proton. And that's the reason that it is called beta elimination, because a beta proton is lost in the process. Alpha eliminations are those in which two groups are eliminated from the same atom. Like in this example, you can see the chloroform. In the presence of a base, that is sodium hydroxide, it loses a hydrogen halide and we get a carbene as a result. But this species, the carbene, is very much reactive and unstable and cannot exist for longer, and so it will automatically undergo further reactions. The beta eliminations, in which groups on adjacent atoms are eliminated with the formation of multiple bonds. Here again, this is a alpha carbon, and in the presence of a base, it loses the halogen and a hydrogen from the adjacent carbon, and we get the unsaturated compound. How the beta eliminations are proceeding, how these reaction proceeds. Beta elimination proceeds through two mechanisms. These are E2 bimolecular elimination reactions and E1 unimolecular elimination reactions. What is the difference between these two? As we have discussed in the case of SN1 and SN2 reaction in the substitutions, nucleophilic substitution reactions, they are analogous to the SN2 and SN1 mechanism. They differ only in the timing of bond cleavage and bond formation from each other. The unimolecular elimination reactions, the E1 indicates that elimination is unimolecular. E1 reaction proceeds via two-step mechanism. One is the bond to the leaving group breaks first before the pi bond is formed. The slow step is unimolecular, involving only the alkyl halides. The heterolysis of the chlorine bond from a carbocation, this is the same step as that is SN1. It is the rate determining step and it has a first order kinetics. Like if you see this molecule, in the first step, that is slow step, the halide is removed and we get a cation, carbocation. This is the first step. In the second step, the base like H2O removes a proton from the carbon adjacent to the carbocation, that is a beta carbon. The electron pair in the CH bond is used to form the new pi bond. This is a fast step. The water attracts a proton and it forms a double bond with the adjacent alpha carbon. Types of elimination reactions. One is like dehydrohalogenation. In this, a hydrogen halide is removed in the presence of a base from the substance or substrate, and we get a new pi bond. A new pi bond is formed between the previous alpha and beta carbon. This is alpha, to which the X was attached here, and this is beta carbon, to which the proton was attached, or from which the proton has been removed. Dehydrohalogenation, that is, okay, this is the slow step. First, a carbocation is formed, then in the presence of a base, it's a pass step, the proton is removed, and we get a double bond or unsaturated between the two carbons. The second one is the dehydration or removal of water. In the presence of a strong acid, the alcohol may lose a water molecule and we will get an unsaturation or a double bond between the two adjacent carbons. This is the mechanism of this reaction. First, the proton is added to the hydroxyl group and we get an hydronium ion. Then the water is removed. This is a slow step and we get a carbocation, and then comes the fast step, that is the removal of proton from the adjacent carbon and the formation of the double bond. References for these reactions or for these lecture, this nearly all the elimination will be covered from these three books. If there were some other books consulted, so I will inshallah convey it to you also. Okay, thank you very much. Thank you. Thanks a lot. Allah Hafiz.